This course uses peer review. Each student's answer script is graded by 3 other randomly selected students. So each student basically gets 3 candidate grades, hopefully more or less similar, and we have to choose a typical value. Aha, isn't that a central tendency problem? Yes, it is. And this is how we shall proceed. First, we need to make sure that the 3 grades are indeed similar, that they do have a central tendency. If not, then some intervention is called for. But otherwise, we need to choose a measure of central tendency. Should we choose mean? Well, let's see what may go wrong if I do. Suppose the grades are shown in a number line. Here, 2 are pretty close together while the third one is much lower. Now, if it is very low, then of course we shall flag the situation as a no central tendency scenario and intervene. But suppose it is quite low but yet not too low. If we take the mean, that will be somewhere here. You see how it gets influenced by that far off value? Such far off values, as you already know, are called outliers. Mean has this problem. It gets affected too much by outliers. So we do not use mean here. We use median, which is the central most value and not affected by changes in the extreme values. In this video, we shall see how median is more robust than mean. To demonstrate this, we have these values. How many of them? We have got from row 2 to row 1001. So we have got 1000 values, and I want to compute the mean of all these values. So I compute average of A2 to A1001. So these are the average. This is the average of all these values. Similarly, I shall compute the median of the same values A2 to A1001. And I can see that they are pretty close. So both are 15.1 essentially. Now, when we type values like this, when we do the data entry, it's often the case that due to some typo or something, some outlier will creep in. Suppose when I was typing this 14.28, I just forgot to type the decimal point. So it becomes a huge number, 1428. Now these are the values currently. So I will hit enter, and you see median essentially remained whatever it was, 15.1 effectively. But this immediately jumped up, not that high, not something close to 1428, because the other points are pulling it back, but this 1428 does have some effect on the mean, but much less effect on median. So this has become 16.55, whatever. Now suppose I do the same mistake with another value. So say, for example, I do the same mistake here, 17.13, and I make it again. I forget to type this point here, and I hit enter. You see, this still remains rock solid at that 15.115, but this is increasing. And that is because the moment I forget to type my decimal point, this becomes an extreme point. So it has no effect on the most central value present in my data set. However, mean includes all the things. It will find the total sum of all the things and then divide by the sample size. As a result, this 1713 and this 1428, all these things are contributing directly to the mean, but they are not contributing directly to median. In fact, even if I change it, say, to an enormously large number, I make it this 21,713, median is not going to change. It just ignores every extreme value. But here, mean has changed a lot, but median simply does not take that into account anymore. So you can see that median is more robust than mean. Of course, at the same time, median is more difficult to compute because here the computer has to sort all the values and figure out which is the centralmost values. But for mean, it is merely a question of adding them up. But when you are using a computer, that hardly matters.